Hey, here we are, July 15th in Antigo, Wisconsin. AIG, our airport identifier, and this is the Little Eagle. Registration number of 13, in November 13, Golf Kilo. We built this in 98, been flying it. Got just about 500 hours on it, which isn't a lot, but we've been doing a lot of other activities. And here's our instrument panel. Left to right across the top is altimeter, airspeed, tachometer, and hour meter. And in the center is a little clock, and below it is a turn indicator. You want to keep the ball in the middle. Step on the ball. Give it the rudder pedal if the ball sways off one way or the other. And below that is our exhaust gas temperatures, front and rear exhaust gas, front and rear cylinders. On the left is a CHT, cylinder head temperature, and a primer. Altimeter, ammeter, and our radio, and the throttle. The stick in the middle with a push to talk button for the radio, and this on the top is just to keep it from moving around if you have any winds while the plane is parked. Fuel tank in the middle between your legs, and the rudder bar, rudder pedals down there on the bottom. Right there. Widest point on the plane is the seat, 24 inches. From there it's 6 inches narrower at the front, and of course tapered back to the tail. This is for our airspeed, our air instruments. This is a static port. There is 8 holes, 40 thousandths inch diameter, 90 degrees of each other. That measures the ambient air pressure. And this is a pitot tube. Just that air pushing against that is what deflects our airspeed indicator. Stock wheelbarrow tires, about the 7th or 8th set of those. I get a little eek when you set down. We have a float in our fuel tank for a fuel gauge. Our engine is a 440 Kawasaki 2-stroke engine. Down here is our gascolator. Basically it's a gas strainer and a settlement bowl if we should get any moisture in the gas. To prevent moisture, fill your plane up with fuel so there's no air in the tank. At night when the air contracts, it sucks moisture in, cools down, condenses out water. That's how you get water in the fuel. Our old airport manager, instructor, pounded on there on our heads. Fill your plane up when you're done using it. Our drive is a 3-inch pulley running to an 8-inch pulley, 5 belts. It's actually, I'm told that's good for 60 horse, and this engine is 40 horse, so we're well built. The shaft is stationary. We have 3 sets of sealed bearings inside the pulley. So we're basically just bolting the propeller to a pulley that's turning on a shaft. Very simple. We shim it to tighten the belts. could have a cam, but there's a possibility of the cam twisting and loosening up the belts. Notice these bolts come from the bottom up. The reasoning is you're thrust loading against the bolts. I had the bolts going down, and a textbook. Bending bolt, sheared at the first thread. I wonder why my performance wasn't real good. I was out close to the airport. I noticed it was just was doggy. Well, I looked up there and I seen the head of one of the bolts spinning the bead here. I said, oh, that'll do it. So we came in, landed, and changed it. Been good over 400 hours. Also, we had a snap ring that holds the bearings in. So along with that, I made aluminum spacer and put drilled and tapped 5/16 bolts, and those are put in for safety and safety wired. Good flying little airplane. Excellent visibility. I couldn't have built something better. This was built from the blueprints of the Pete and Paul, scaled down to a 9/10 version, and only one seat. With the engine mounted as high as possible, the plane sits relatively level. We can still get a good flare on the approach and land it, and I have excellent visibility. It's short. It will learn you how to land a tail dragger. On the wings, we added an inspection plate. That gives me access point to check the bolts in the wing, where these fittings are bolted onto the spar. That was my dear wife's idea. It was a very good idea. Plane's all wood, wings are fabric covered. You glue the fabric on, and then you shrink it with a flat iron. You calibrate your flat iron against the scale. And it's 3-piece wing. So this is the fairing strip just to cover the gap. And we have an external antenna for our radio. Now, the new plane, full scale per print, Pete and Paul air camper, powered with a Chevy Corvair engine. It's 1964 Corvair engine, completely rebuilt. It's a William Wynn manufacturing project. I got all my points from flycorvair.com, and instead of the blower that went on the top of the engine, it has the eyebrows, they call them, and that forces the air down through the cylinders. And this is our large oil cooler, and he is also baffled at the back, so the air comes in, has to go through the cooler. I think I have a lot of respect for these engines. I had a couple Corvairs just out of high school. I had a Corvair pickup truck and a Corvair van. And fins were all covered with dirt. Oil cooler was plugged. My buddies were riding in the back of the pickup one day and they fed a loaf of bread into the blower. So you take an aircraft where it's new and well maintained, I believe it will last me as long as I want to fly. Also, it is a dual ignition in respect to the distributor has the points on one side and a solid state pickup on the other. And that powers 2 coils, 2 condensers into this diode, and that in turn goes to the center of the distributor and out to the single spark plugs. Usually we have a problem with the coil or condenser or the points. Well, this eliminates that. As seldom do we have a problem with the spark plug itself. And I have slider carburetors. Put one on each side. PVC pipe for air induction system where the air comes in. And down in the bottom cowling we have a carburetor heat. It's a butterfly that either it takes air from outside through the air cleaner, or the baffle closes and it takes the air from the engine. The warm air prevents carburetor icing. Slide carburetors, you have a minimal problem with icing because the slide is the throat that opens and closes versus a carburetor at the butterfly where the chamber, the venturi, can actually close up. If you carburetor icing with a slider, I'm told you can just pop it wide open and it'll suck the air or suck the water through into the engine. We have a John Deere alternator and the starter. This is all William Wynn manufacturing to make the plate for the top where the blower went, and the brackets and the starter. Real good set, good looking set. This engine also has an extra bearing on the PTO, the power takeoff end, where we bolt the propeller, and an extra line that comes up to it, and an oversized water pump, oversized oil pump. No water pump on an air-cooled engine. So we ordered some fittings. We needed to change the hoses for the oil cooler, and we are basically ready to start this. Bolt the propeller on. I have a carbon fiber propeller. Two advantages. I can adjust the pitch. How good is my engine going to be? How much horsepower is it really going to be from engine to engine? Well, I can adjust the pitch. So your full throttle RPMs are such, and so you can add pitch to the blades or take it out, whatever you need. And also, a wooden propeller, you can bust the propeller and lose the end off it. You lose 6 inches off the end of one of the blades, it's going to go so out of balance, the vibration will rip the engine off the aircraft. It'll become tail heavy and you'll fall to the earth tail first. Carbon fiber will not break the end off. Our struts are 3 layers of 1/4-inch plywood. Cabinet plywood has no voids. It's solid because when you're making cabinets, you can always, the end's going to be visible. And it's Resource No Glue. It's Russian birch, Menards special, and glued together with Titebond glue in a fixture. And they're pretty and they are strong. I did test one. I actually had a sample left over. And over here in my messy bench, I like to test my work. I'm the poor soul that's got to climb in that thing when it gets done and fly it. So I tested my brazing. People tell me there's no strength in brazing. Well, 2 pieces of flat stock, ground down to a point, laid out flat, brazed, and then put in a press and bent. I'm told the secret is you want to see wetting on the brazing, just like if you're familiar with the wetting when you're soldering, you want to see it wet past. Then you've got good absorption and penetration. Brazing is a metallurgical process. It's not a glue. there is a bond with the parent material. I did one, it turned out so good. I did another one real quick and threw it in the press and videoed it. Maybe I'll show that on another video. And bent it. My struts, I had 1.5 inches scrap left. And put that in the press. This guy here, the jack, picks this up. I drilled in, put a gauge, 4,000 pound gauge, and I could have got a bigger jack, but I didn't think I'd have all that much strength. When I jack it up, the full load at 4,000 pounds is 2,400 pounds on whatever you put in the fixture. And yeah, the inch and a half piece of scrap, I pumped all the way up to the 2,400 pounds. And I pulled on some of my brazing, same thing, take it all the way up to the limit of what the press will do. Also, this plane has suspension. It's got a spring in here. I got McMaster spring, car spring. I could have put under more tension. Sitting on the ground, it really should be, I don't know if it's going to make any difference. I was hoping to see it pulled all the way in and not collapsing the spring already. We will head around to the back side, look at the instrument panel. Fuel tank is a 14-gallon Summit Racing fuel cell. That gives me a camel look on the center section of the wing. I started this plane in 2012. Yeah, I'm not as flexible as I was 10 years ago. So this I added after the wings were done. It's 1/4-inch plywood. I wrapped it in a jig, glued it, and put it up here, and then put all the pieces behind it that I needed to get proper lengthening, glued it in, and then belt sanded to get the contour. And that was the trick. And added fabric and added the fabric, cut the fabric, pulled the fabric back, added fabric, retensioned it. And here's our instrument panel. So we have our altimeter, tachometer, compass, airspeed indicator, hour meter, turn coordinator. And down here we have engine instruments. We have fuel gauge. Fuel cell comes with a gauge. Just got to find the proper fuel cell comes with a sending unit. I just needed to find, I think it was a 60 ohm fuel gauge. Voltmeter, ammeter, temperature. It's actually a water temperature gauge. And trick was getting something that was long enough to reach up to the engine to measure your oil temperature and oil pressure. And got 2 temperature gauges here. There's something I don't understand, don't remember. I have to look in my manual. For what I did. Cylinder head temperature. One is cylinder head temperature and one is oil temperature. That's what it is. And over here is our primer, and this is our carb heat. Use carb heat when you're landing. so you don't get the carburetors ice up and kill the engine. And down here are controls, same thing, control stick, elevator, bank, the ailerons on the wing, and we have the rudder pedals way up a ways. The front seat is actually, the front passenger actually sits between your legs here. And we added a door on this side to make it easier to access the front cockpit. That is a problem. It's close quarter. And a little glove compartment in the front. Also, I have dual controls, front and backs, in this plane. And underneath there, that's our battery box. Up those short straight pipes on the exhaust. And this here is where we slide a tube up to the gascolator, that drain. And spring load, you push it in and the gas will run out. So you can see that you don't have any water in there. Another question I had was the residence time. If we run our fuel lines into that engine compartment where it's hot, is it going to vaporize our gasoline? So this was a way of eliminating that. Everything is inside the compartment and the fuel lines come up to a T and then they split and go to each carburetor. So that eliminates problem of getting the gas to vaporize. So not a lot left to do here, and we will have this inspected, and then we need to fly off 40 hours locally, and then we'll be ready to go with it. These are jury struts, the wooden struts, flex. And so these need to be put in, and they're connected to the spar that runs through the backbone of the wing. The little plane doesn't have them because the steel tubing didn't flex. I didn't need it. So this will be our new plane.